All right, let's talk about one of the most critical steps in any AI project, model training. We're going to dig into the huge gap between just kind of winging it, the amateur approach, and building a real professional pipeline that's going to save you time, money, and frankly, a lot of headaches. Okay, let's just get right into it. I want to start with a horror story, one that I think is painfully familiar for a lot of people out there. Just imagine, you've been babysitting a model, it's been training on your laptop for 3 solid weeks. You're almost there, and then the laptop crashes. Everything gone. You're right back at square one. And this is where it really hits home. Look at the difference here. The disaster scenario took 3 weeks, which after the crash turned into 6 weeks total. The professional pipeline, it took 2 days. Instead of being so fragile that a crash wipes you out, the pipeline is crash resistant. Instead of being impossible to reproduce, it's perfectly versioned. This isn't just a small improvement, it's a completely different universe of working. So yeah, that story, it's not just some one-off anecdote. It represents a super common, incredibly costly, and honestly, a totally avoidable disaster that happens when we don't treat model training like the serious engineering discipline that it is. The source material had this brilliant way of putting it. The chaotic, manual way of doing things, that's like a student cramming for an exam. You've got no notes, no practice tests, you're just throwing random stuff at the wall and you forget it all the next day. A professional pipeline, though, that's like a structured education. You're taking systematic notes, doing regular quizzes, building knowledge that's solid and reproducible. So why is this cramming approach so dangerous in the world of professional machine learning? Well, it's because the stakes are just incredibly high. You know, the pain of that one data scientist losing all their work is really just the tip of the iceberg. This whole lack of structure, it represents a massive, massive risk to businesses that are depending on these models to actually work. And let's put some numbers on this to see just how big the stakes are. The annual business value driven by machine learning models is estimated to be over $1 trillion. And what about the cost of training? Well, for a big model like GPT-3, a single training run could set you back about $4.6 million. And to even make that happen, training GPT-4 reportedly needed something like 25,000 GPUs. I mean, at that scale, you just can't afford to lose your work when a machine crashes. So the big question is, how do you manage all that complexity? The answer is by adopting a professional ML pipeline. This is the system that takes the messy, chaotic art of building a model and turns it into a repeatable, scalable, and reliable engineering process. And at its heart, this pipeline just follows the standard machine learning lifecycle. It all starts with getting and prepping your data, then you move into the actual model training, then you have to rigorously evaluate how well it did, and finally, you deploy it out into the real world. A professional process manages every single one of these steps like clockwork. The discipline that wraps around this whole process is called MLOps. The easiest way to think about it is like DevOps, but specifically for machine learning. It is the engineering backbone that makes sure models aren't just built once, but are versioned, deployed, and managed reliably when they're actually in production. So how do we actually build these pipelines? It's not magic, right? It's all about using the right tools for the job. Let's take a look at a few key categories that pretty much every professional is using. First up, experiment tracking. So instead of scribbling notes in a random text file or trying to remember which combination of settings gave you that one good result, tools like MLflow act like a perfect, meticulous lab notebook. They automatically log every parameter, every metric, every model you build, making all your work completely reproducible. Next up, hyperparameter tuning. Remember that analogy about finding the best study method? This is exactly that. Instead of you manually guessing and checking things like learning rates, tools like Optuna automate that whole search. They systematically find the best settings to squeeze every last drop of performance out of your model. And finally, cloud platforms. Think AWS SageMaker. These are the tools that let you break free from the limitations of one laptop. They give you on-demand access to tons of powerful GPUs, they handle all the complicated infrastructure for you, and they can slash your training time from weeks down to just days, or even hours. Okay, now that we know what a professional pipeline looks like, let's make this really practical. We're going to walk through 3 of the most common rookie mistakes and show you exactly how to fix them. All right, first question, and be honest with yourself here. When you get a new data set, do you just dump all of it into your model for training? If you do, your model is essentially memorizing the answers to the test. It's called overfitting. A pro always splits their data into 3 separate buckets: one to train on, one to validate and tune with, and a final, completely untouched set just for testing. This is the only way you can get a true sense of how your model is going to perform on new data it's never seen before. Okay, second question. If I asked you right now to reproduce the exact model that gave you your best results 2 weeks ago, could you do it with 100% certainty? Without experiment tracking, the answer is almost always going to be no. You're just randomly changing settings and hoping for the best. A professional uses a tool that logs everything automatically. And this isn't just about being neat, it stops you from wasting weeks of your life rerunning experiments because you can't remember what you did the first time. And for our final mistake, let's bring it all the way back to that horror story from the beginning. You're training a huge model, it takes days, it's 95% of the way done, and the power goes out. What happens next? For the beginner, it means starting over, from scratch, losing all that time and all that expensive compute. But the pro's fix is so simple and so powerful. Save a checkpoint of your model regularly, maybe after every single epoch. If it crashes, you don't lose days of work, you lose minutes. You just load up that last checkpoint and keep right on going. So let's end on this question for you to really think about. Take a good hard look at how you work. Is your process a fragile, ticking time bomb just waiting for the next crash or that one parameter you forgot to write down? Or is it a robust, reliable, professional pipeline that's ready for the real challenges of modern AI? The choice really makes all the difference.